Alright, so what we want to do first is take the square root of both sides here. Alright, we got x plus 2 to the second power equals 12. We're going to take the square root of both sides. So I got square root of x plus 2 squared equals square root 12. Now, when you take the square root of something that's squared, they just undo each other. And so all we're going to be left with here is just x plus 2. And I don't even really need the parentheses there, but I'm going to go ahead and put them there for right now. So that's what that would reduce to. It would just be x plus 2. Okay, well over here, we got the square root of 12. Can we simplify that? And the answer is yes, because there's a perfect square hiding in the number 12. And when you're trying to figure out, if there's a perfect square in the number, really the main numbers you're going to be looking at are numbers like 4 and 9 and 25. And I think in this lesson, these are probably the three main ones you're going to have to worry about. Okay, so can I divide 12 by any of these perfect squares? And the answer is, yeah, I can divide 12 by 4, and I would get 3, right? So this is the same thing as a square root of 4 times 3. Well, what's the square root of 4? Square root of 4 is just 2, so we can move the 2 to the outside like this, and we get 2 square root 3. And now I'm going to remove the parentheses from the left side. So we have x plus 2 equals 2 square root 3. Oh, one thing I did forget to do. When you take the square root, you end up with a plus or minus. How could I forget? We have to make sure that we get that plus or minus in there. And so this would be plus or minus. And this would be plus or minus. We have to remember the plus or minus. But now that I've done that and filled that back in, all I have to do now to finish this problem is subtract 2 from both sides, right? So when I do that, what I'm going to get is a minus 2. I'm going to go ahead and put it out in front. Plus or minus 2 square root 3. So these are the two answers to this problem. And it's helpful to remember sometimes that this is just a shorthand way of writing out two separate answers. It's the same thing as 2 plus 2 square root 3, negative 2 plus 2 square root 3, and negative 2 minus 2 square root 3. And don't forget the plus or minus the way that I did. Okay? All right. Coming down now to 26. So here we have an interesting problem. We've got two trinomials, one on the left, one on the right. So we need to do some reducing first. And what we're going to do is we'll subtract an x from both sides, and the x's will just cancel each other out, right? If I subtract an x from this side, subtract an x from this side, they undo each other, and now I've just got 5x squared minus 2 equals x squared plus 7. Okay, well now I want to get all the x squareds on the left here, so I'll subtract x squared from both sides. And now I've got 4x squared minus 2 equals 7. And now I just need to add the 2 to the right side, and I get 4x squared equals 9. Okay, so now I need to get x squared all by itself, and the way that I do that is by using an inverse operation, right? What's the opposite of times 4? It's divided by 4 or divide by 4. And now I get to x squared equals 9 over 4. Alright, one last step. I have to take the square root of both sides. That was the first step in the last problem. It's sort of the last step on this problem. I take the square root of both sides, And remember, if you're taking the square root of a fraction, you just take the square root of the top and the square root of the bottom. So this is going to now be plus or minus. I'm going to remember my plus or minus now. 3, because the square root of 9 is 3. The square root of 4 is 2. And then, of course, the square root of x squared is just x. So that's all we have to do for this problem. We don't have to simplify any radicals, and we're done.